your eyes up, don't take any notes, drop the pens and pencils. Okay. I'm going to try and do it nice and large. And also, I've got to think about this. I'm going to try and do it so the sides are a little bit uneven. I'm taking a little more care than I might normally with this initial cube because I don't want anything to happen that's going to screw up your ellipse demo. See, like I'm not quite happy with this. Need to go a little bit further out. Okay, so there's our basic cube. All right, so I'm going to do the one on this side, and then I'll do the one on the top, and then I'll do the one. Actually, I'll do this one, and then this one. All right, so here goes. First thing I'm going to do, again, keep your eyes up, don't take any notes. I'm going to bisect it. Find the center. Once I find the center, I'm going to draw, well, first of all, loosely sketching the minor axis. So the minor axis is going to be something like that. I'm going to double check it here just to be on the safe side. Yeah, that's pretty good. Okay. All right, so there's my minor axis. Here are two midpoints. Here are my other two midpoints. Everyone okay so far? Okay. And again, you guys, if I do something and you don't understand what I just did, stop me and I'll explain. Okay? So at this point here, I've got, this is going to be my minor axis. I'm going to imagine a curve going up like this to here, and it's going to hit right about there. It's a guess, but it's a pretty good guess. You know, I'm going to start here. I'm going to imagine a curve sweeping down to hit here, and I'm going to hit right there. Now look, notice how the center is a little bit closer to this one. Yeah.
Okay, right when it hits the minor axis, is that where it starts to curve off the actual side?
No, it's already technically. If you want to blow this up, it looks like this. It comes off the side right there. You know, as soon as it leaves this point, at this point, it's tangent to the square for just an instant. And then it's at that point, as soon as it comes off, technically it's coming off instantly. The next point in the circle is off the square. Okay, now it looks like it's almost on the square because the square is like right there. You see what I mean? But it only shares, the circle and the square only share 4 tiny theoretical points. Yeah.
We don't need the triangle shape?
No, I usually don't draw the triangle. I draw the triangle only to explain to people the logic of how I'm arriving at that. You know, but once you guys understand how I arrive at that, I never draw it again. Yes. What was that?
Like that, like the minor axis.
Oh wait, I can't hear you.
How do you know where to put the minor axis?
Well, the minor axis has to go through the center, and it has to be going to the opposite BP. So I know it has to be a line like this instantly. Now, as far as the length of it, that's where I'm starting from a midpoint and sweeping up to the next midpoint and seeing about where, I'm guessing about where it's gonna hit the minor axis. So it's a guess, but it's a pretty darn good guess, because I'm not gonna go like this. Actually, you guys, let me draw it again in an enlarged view. So if this is my midpoint, you know, my normal sweep would be like this, and that would be my guess, right? I'm not gonna go like this. You see what I mean? Because that just doesn't make any sense. And that would take me inside the diamond and all the other things. So, you know, what I'm doing is I'm just kind of envisioning that sweep, and that's a pretty good guess, you know, and it confirms my guess when I subdivide these, when I divide this distance in half, and I end up right about there, just in front of the center, then I kind of go, yep, good guess. You see what I mean? Because if I guess anywhere else and my major axis ends up somewhere over in here.
Just to backtrack a little bit.
Yeah.
When you look at the minor axis, do you usually bother to check if it passes through the opposite midpoint, or do you just go by?
Truly, no, I don't. I basically look at these lines, and I'm good enough. I can draw those lines. And those may not converge perfectly to a point, but they're pretty darn close.
Okay.
So, especially when I'm sketching, I just go usually by the convergence rate. Now, if I really cared about it, like today doing this demo, okay, maybe I'll be just a little bit more careful. You know, and for you guys, it wouldn't hurt, because like I know when we look at your 20 cubes, I know we're gonna find ones where it's like, okay, you know, the minor axis is going off at a strange angle. But, you know, truly, no, I don't do that.
And then also, when you bisect the minor axis to find the major axis, it should never align with the center. Because-
Okay, I'm gonna clarify something. Basically, yes. The only time the major the only time the major axis will pass through the center is when it's a circle. Technically, that's not an ellipse. You know, at 89 degrees, it's still at 89 degree ellipse, the major axis is slightly off the circle. You know what I mean? At 90, then it goes through the circle, but then technically it's not an ellipse anymore. So, so yeah, basically, a major axis will always be slightly in front of the center of the square, just a tiny bit. Yeah.
So I asked this yesterday, but so the more foreshortened it is, the closer the midpoint is to the front. Since at the circle it's exactly on it, would it be more off as the
You know,
foreshortened?
I wouldn't really, technically, maybe. You know, the thing is, it's really not something I worry about, and I would encourage you guys not to worry too much about it either, because what I would say is let it fall where it falls. What you should worry about is bisecting the minor axis and making sure that it's not on the center. You know, as long as the major axis is falling in front of the center, you're in the ballpark. You know, yeah.
So it would fall in front of the center in the sense that it's closer to us, it wouldn't be
Yeah.
behind it?
Well, let me show you guys in this example. Okay, if I draw a square like this and I bisect it diagonally, you know, I get a center point there. Well, look at its distance here to here versus here to here. It's always going to appear to be farther back there. Now remember, the ellipses are symmetrical. So you could actually find the major axis on most squares just by doing something like this. In one point, you could just go like this. There's the major. It's going to be halfway between these two midpoints. You see what I mean? So in this case, the major's gonna be right there. And I don't even, I can know that instantly, just because I'm in one point. Yeah,
How do you determine the curve?
in one point?
Yeah.
Okay. I love how when you guys explain things, you do you use your gestures. So when you say the curve, you mean the curve of the ellipse?
Yeah.
Okay. So watch this, you guys. Look. So here's the midpoint. Okay. Now here's something that's going to mess with your head a little bit. Okay. This is actually a great discussion to be having because this is going to mess with your head. So we've got midpoints here, and I can go like this, and I can go like this. But wait a minute. Here's where you've got to realize. If you go from here, hi Eureka. I love how she tries to sneak in quietly, like, no, the door opens so soft. So, let me blow this up, kind of like what we were doing on some of these other ones. You guys, we've got a midpoint here, and we've got a side going like this. Do you see that as the ellipse curves, the ellipse is going like this. It's the same angle as the side right here. And then it kind of comes out and it appears to like hug this line for a little while because it has to come out to here to hit a major axis. You see what I mean? You can move that if you need to. So see, it starts here, but the visually widest point is going to be like out here somewhere. That's going to be one of the harder ones to judge. Yeah, Nikki.
If I remember from one of the previous classes, they told us to like avoid flat lines. Isn't it supposed to be round regardlessly still?
Yes, it is, but watch. It's going to be. What I would have you do is I would almost have you ignore the midpoints to some extent, worry more about the symmetry, and worry more about the axes. So if you know you're going to be, if you know like, what you need to imagine is you need to imagine this sweeping out a little bit, being bisected, it sweeps out to here, and then worry about your symmetry. See, it's still symmetrical, but it's symmetrical around the axis, not symmetrical around the square. They're two different things. Does that make sense now?
Yeah.
Okay. Now, everyone okay with me continuing with this? All right. So again, you guys, keep asking these questions because this is exactly the kind of stuff I want to clear up. What is it? Yes. The major and minor are always going to be straight lines, and they're always perpendicular. Yeah, Kendall.
So the minor axis cuts the major axis cuts the minor in half.
And vice versa. Okay. So the major and minor bisect each other. So if I bisect this line, I get a point here, and the hard part here is, do you see how this line is just slightly angled? The hard part is that you need to slightly angle this and keep it 90 degrees as well. So I'm going to draw it a little bit more carefully than I normally would. And so this is a 90, and it's a little bit in front of the center, and that's the orientation of my major axis. All right. Now to get the length of it, I'm going to do the same thing. Again, you guys try not to take notes. Try and just keep your eyes up. I'm going to do the same thing here. I'm going to sweep this out a little bit, and it's going to hit about there. When I go like this and I double it down, it comes out about here, and that makes sense based upon this line. And there's the beginnings of my ellipse. Now when I go to actually draw it, I'm going to draw it in a color here. And you get something like that. Now if I tighten it up, you guys, if I want to draw a really careful ellipse, this is, it's funny. I was looking over my notes last night, re-editing them for today, and I saw this comment, and I went, what the hell does that mean? And I just went, oh, that's what that comment was about. Basically, the comment was a mechanical trick. If I'm really trying to draw a precise ellipse, I wouldn't do this for casual ellipses, but if I really want to make it precise, I'm going to draw it so that my hand is always on the inside of the curve. I'm not going to try and draw this. I'm going to draw this. You see what I mean? So I want to keep it so that my hand, when I'm doing these more and this is only for the precise ellipses, where when I'm drawing each quarter of it, I'm going to draw with my hand inside the curve. It's going to make it easier to keep it symmetrical. It's not quite symmetrical. This needs to sweep out just a little bit more. But do you guys get the idea? Yeah.
So, just for clarification, when you find the major axis and then you want to determine the length of it from the top because it's closer, because I think I realized what I did wrong was I got obsessed with the tangents and then I didn't, that's why my list would look weird because I forgot about making all the quadrants the same
Yeah.
size.
You might give me another water. There should be a bowl. Yeah, that'd be great, thanks. So I'm really glad you asked that because here's what I'm willing to bet. When we go looking through these, almost all of you can, when we go to look at them, you'll look at them and you go, oh, these don't look any good. And almost all of you will be able to point to something like that, like, oh, you forgot symmetry, someone else forgot the orientation of the minor axis, someone else forgot to keep them perpendicular, someone else forgot to bisect them. You know, that's why I go over those 6 things that I want you to memorize. I want you to memorize those 6 things about ellipses so that you can just tick them off like, you know, the favorite, the members of your favorite band. You know, I want you to just know them. Because that, if you memorize that stuff, you almost can't go wrong. You know what I mean? But today is why we're doing this, because almost everybody in this pile forgot something. And if you recognize that I forgot to make them symmetrical, you know, well, that is important. And as long as you realize that today before you go, so that next time you remember, you're in business. You know, don't worry about it. This is exactly why we're doing this, you guys. And it's important. It's important that I'd rather take extra time on stuff like this than anything else, because this is like the stuff that's going to stick with you for the rest of your career, and you're going to be using it every day for the rest of your career. You know. All right. Everybody good? Yeah.
So on the major axis, the distance after it hits the end of the circle to the bottom, the end of the ellipse to the bottom.
Right here?
Yeah, versus the distance on top. Is that just due to foreshortening, the fact that those are different?
No, these should be pretty close. Let me see how far off I am.
No, I mean from the end of the ellipse to the bottom.
Oh,
On the major axis.
from here to
Yeah.
here. Oh yeah, those are going to be different because of foreshortening. Yeah.
And then were you saying that when you first do the ellipse to do the top ones? 'Cause then
Yeah,
they're
I would
really-
start on the one nearest the eye level.
Oh, okay.
So like the top one if it's under the eye level, the bottom one if it's above the eye level. Because what's going to happen, you guys, is wait, guys up, keep watching. You're going to underestimate this one. You're going to overestimate that one. And so you actually kind of want to split the difference, but this one will keep you within the square. If you double it, this one will make you go outside the square. Thank you. You're easy. Any other questions? Okay, you guys, take a minute. Write down any notes that you think you need from this, and then I'll do the next one. So just take a minute or two. Write down any notes you need.